Okay, so having plotted the graph, we now need to calculate the resistivity. Now, the equation we used to base all this on was resistance equals rho L over A. And we replaced that with V over I, voltage over current, equals rho L over A. Rearranging that slightly gives us V rho I over A L, which if we compare to y equals mx plus c, with x as our x-axis being length and our y-axis being the mean voltage, that means that the gradient of our graph is equal to rho I over A. So rearrange this to work out the resistivity, gives us gradient times area divided by the current. So M is the gradient from the graph. I is the mean current. Now, this is a value which we wrote lots and lots of down for every length. So you're just going to take the mean of all of those values because it shouldn't change. So it's not like a repeat reading the same way you did voltage, but you've got lots of readings across all the lengths. So just take a mean value of those. A, of course, is the cross-sectional area. Now, pi r squared would be what we'd use if we'd got radius, but we've got diameter. So pi d squared over 4. So what we can say, rather than working out A and then putting it in, which just gives us extra steps, do it all together. So we're going to work out the resistivity using gradient times pi d squared over 4 times the mean current. So your job now is to go to your graph, work out the gradient. Don't do this too small, so don't do it in a little triangle there. Nice and big, but try and stick within the points. And gradient, remember, is change in y over change in x. Or in this case, change in v over change in m. So that gives us the gradient. The diameter needs to be in meters. So make sure you've converted that. And the current needs to be in amps. Shove all those numbers in and you get your value for resistivity. Remember that if you've done everything in SI units, which you should have done, the final resistivity will be in ohm meters. So at this point, you can go and look at what the actual value for your metal would be for the resistivity. So if it's way off, although do check you're looking at the right units, you can go back. The chances are what you've done is misconverted a unit. So your lengths on your graph aren't in centimeters, for instance, or something still in millivolts, or you've not converted the area for the diameter or something along those lines. So it should be ballpark. It's not going to be exact, but it should be close. So if it's factor of 100 or 1,000 out, that's down to units. If it's 1.6 and it should be 4.7, that's not a big problem. Don't worry about that. But it's the times 10 to the power of, it's the order of magnitude you want to double check.